Hey Techno Studs, in this video we're going to talk about this first section before we get further in depth into this. Now the reason why I'm covering this is because when you dig down deep into each one of these, it's going to show you all of the communication, and there's going to be a lot of repeat information in this. So what we're going to do is we're going to just cover the general TCP IP communication, and then that way when you identify it further down, you can dig into it if you play around with this tool, but for the purposes of my video, I won't dig in as deep into it. So when we're talking about the network layout, what we're gonna do is we're gonna analyze the communication and what would happen if the demo laptop sent a packet to the web browser. So what the packet is going to do is it's going to traverse across this switch into this router, and the router is going to process it, and then it's going to go to this router, and that router will process it, then it will go to this router, and that router will process it, and then it will go to this web server. So that's the path that it's going to take, and let's take a look at a further in-depth look into that. So I have this client request service from a server. So that's the demo laptop is requesting a service from the server, and then in this case, it doesn't really matter, but later on, we're going to actually be requesting a website. So I'm going to open this up, and I'm going to take a look at it. And then the first thing that happens is the application. If it's a web page, it would be something like a browser. If it was FTP, then it would be some sort of FTP client. The FTP or the application is making some sort of request. And so it's got to form the request in something that the other application on the other side can understand. So on this side, it's a client application. On the other side, it's a server application. The client application needs to format this data, this payload, in a format that the client or the server application is going to understand. So there needs to be an understanding of how that data is going to come in. And in order for these two to communicate, to plug together, for the client to be able to make this request of the server and for the server to reply back to the client, we have this gap in between. There is a distance in between. There are two different machines, and we need to network these two machines, and we need to span that gap. We need to somehow communicate across that gap. So that's what the rest of this does. So what the client machine will do is it will first of all create a layer 4 and a layer 3 out of this. So layer 4, it's going to put in the source port, the destination port. It's going to have some sort of sequence number, acknowledgement number, flags, protocols. So it's going to fill in this data into here of where it's destined to, where it's going to be heading off to. And then once it does that, now it needs to go through this Ethernet process of creating the layer 2 and layer 1. And so to do that, it needs to know the MAC address, because we know that from this demo laptop to this web server, it uses IP address to route that information. But to go from this demo laptop to this router, it's got to go through the local area network. And on the LAN, it uses a MAC address. So it needs to determine what that layer 2 destination address is. And in this case right here, it's routing this to a remote network. And so it needs to know the MAC address of this router. So I could actually look into this, determine the layer 2 destination MAC address. It looks at the routing table. When it looks at the routing table, it determines that this is a remote address that it's trying to go to. And so it within the routing table, it shows the gateway that it needs to route to. And so what it will need to do is figure out what the MAC address is of that gateway. And so what it will do is go through an ARP request to figure out what the MAC address is of this gateway right here. And so what it will do is it will look at, first of all, the ARP table and see if there's a cached version of this IP address to the MAC address. It's looking at the IP address of the default gateway. So in this case right here, it's looking at this 10.1.0.1 because that's what it found in its routing table. So it needs to go to 10.1.0.1. So it's going to look in its ARP table for 10.1.0.1 and try to find out what the MAC address is for that. Now, there's a good chance, since this is the router, that it will find that. But if it doesn't, it needs to go through this ARP resolution process. And what the ARP resolution process is it sends an ARP request to this gateway, and then it will receive an ARP response back, and then it will add that address, the ARP response, it will add the information from that ARP response into the ARP table, so then it has it for future reference. Now, how does it send the ARP request out? Well, what it's going to do is we'll open this up, it's going to form a packet. Now, there isn't a layer for a layer 3 to this, because ARP is a layer 2 protocol. And so what it will do is it'll take a look at the packet and frame assembly. It is a ARP request, so this is somewhat how it's formatted for this ARP request. It's a request, and it's going to be the target MAC address. It's going to send it to the destination MAC address of FF, which is a broadcast. So it's going to broadcast it out into the network. So that's the layer 2. From a layer 1 perspective, it's got the preamble. So that's what synchronizes the clocks on the 2 network devices. And then the start frame delimiter, which says, hey, the next bit that you receive is going to be the start of the MAC address. So it's going to start the MAC address, which is this FF, and so then it will then put that out onto the network. Now it's going to hit the switch, and the switch has to process it. So what does the switch do? Well, the switch has 3 jobs. It does buffering, it does learning, and it does forwarding. Those are the 3 jobs that a switch does. It can actually do quite a bit more than that, but those are the primarily jobs of a switch. So a buffering, what it has to do is the MAC address is somewhere within the frame, but so it can't send the frame out until it knows the MAC address. So somehow it needs to store that information that's coming in until it has enough data to be able to know where to send it. So that is where this store and forward or cut through comes in. Those are 2 different options of how it stores within buffering. So the store and forward will take the whole packet in and store it, and then it will send it on its way. Now, the advantage of this is it can do that little check to make sure the frame has not been altered and that it's an error-free frame. Otherwise, you can also set this up as a cut through. And what a cut through will do is it will say, hey, I want to forward this as fast as I can. So there's a fast forward method that as soon as the MAC address is received, then it will start sending it out that other port. And then a fragment free will receive the first 64 bytes. And then once it's got 64 bytes, then it will send it out the port that it's supposed to go out, the destination port. And the reason why it's 64 bytes is because that gives it enough time that if there's a collision that happens, it's probably within that 64 bytes. So therefore, there's less chance that there's a collision and less chance that it's trying to forward something off that there is already a collision. So fragment free can help make sure that you're not sending bad data off of one of these ports. All right. The next thing that a switch does is the learning process. It needs to forward packets out the proper port. So how does it forward packets out the proper port or frames out the proper port? Well, it does that by starting to learn what MAC addresses are associated with every port. And so how it does that is every time a packet comes into the switch, it will take a look at the source MAC address and then record the source MAC address and the port that frame came in on, and it records that into the MAC address table. And so now what it can do is it can start recording, this MAC address is on this port, this MAC address is on this port, this MAC address is on this port, and it has a record of all that. And what that does is it assists in the forwarding process. And that is when a frame comes into it, then it can look up the destination MAC address. so that way it can then see what port it needs to be forwarded out on. So it looks at the source MAC address to be able to log what port that MAC address is on, and it looks at the destination MAC address to know what port to forward the frame onto. Now, if it's a broadcast, it forwards out all ports except for the one that it came in on, and if it is the MAC address is not known, then it will flood it out all ports except for the port that it came in on. All right. So that is the switching process. Then you have the packet frame and frame disassembly. So this has gone through the switch at this point in time. We're going from this demo laptop. It's gone through this switch and now has gone to this device right here. Actually, this is a broadcast, so it's gone out to all devices. And this device right here sees the ARP request and realizes, okay, I need to respond back to this. So it forms a response back. So we can take a look at this ARP response, and it creates this packet and frame to be sent back. And then what will happen is it will send it to the switch. The switch will process it just like we talked about before. And then the packet is then sent to the demo laptop, and the demo laptop unpacks it and takes a look to see how to process or what the response is, and then it adds the response to the ARP table. So it takes the IP address and the MAC address association and adds that to the ARP table. So then it has a reference for future reference, which is important with the router because it's probably going through the router for quite a bit of communication. So then it won't have to keep asking the router. So once it goes to the ARP process, it now has a MAC address and it knows how to assemble the rest of the frame. So it's got this layer 4 and layer 3 that is now passed off to the layer 2, and it creates the layer 2 with the proper MAC address, which will be the MAC address of this router. So the IP address is going to this web server. That is how it's going to get routed all the way to there. But the MAC address is going to this router right here. And so we've got the router, it's going to be fit into this, creating the frame. And then it's got to go through that switch process once again to get this packet, this frame, to the router. And then once it gets to the router is going to disassemble it, and it's going to take a look at it and says, well, first of all, layer 1, it's going to start receiving it. Layer 2, it's going to start looking at the MAC address and say, is this destined for me? That router says, yes, this has the MAC address of myself on there. So I am going to now take that, and now I can process this as a packet. So the layer 1 and layer 2 are ripped away, no longer exist. They're gone. And so now what it's going to do is going to go through this routing process. It does a checksum on it to make sure that nothing has changed, that the packet is still intact and it is still good. The next thing that it's going to do is it's going to take a look and says, the interface that it came on, does it have as an Ingress Acl? So it's this interface right here, and does it have a Ingress Acl, one that is coming into it? Because if it does, then I'll need to check the packet against it to see if it's okay. So it'll check that against the ACL to see if it's okay. All right. Next of all, then it goes through the routing process. This is the process of comparing that IP packet, the destination IP, to its routing table. And it's going to take a look at the routing table and determine what is the next hop or the exit interface that it needs to send this data out. And so it's going to go through that routing process to figure out where that packet should go. It will decrement the time to live and recalculate the checksum. It decrements the time to live to make sure that if there's any routing loops or something, that packet doesn't go on forever. And so then because it changes something in the header, it's got to recalculate the checksum. So it does that. And then it takes a look at, okay, what interface is this going out, which is this interface right here. It's going egress, it's going out. And so if it's going out, is there any outgoing ACL that needs to be processed? And it will process that outgoing ACL. And then we'll put it in the queue to actually exit the interface. So that's what's all happening. This whole routing process is happening on the router. Now, what it has to do is, now that it's assigned to the interface and ready to go out the interface has to recreate the layer 2 and layer 1. So it's going to go through that same process again. Determine the layer 2 destination address. It's got to go through the frame assembly of creating the frame assembly. It might need to do this router right here, might need to do an ARP request against this because it needs to know the MAC address of this interface right here. So we'll take a look at the MAC address, put the MAC address in there. Then it will go through this. Each one of these connections are Ethernet. So I've got them all set up Ethernet because that's the main protocol that we've been using. So there's probably a switch in here. It needs to go through that switch and get processed just like everything else. So it goes through that switch process, which we've already talked about. Then it goes through the frame disassembly. So that means that it's gotten to this router. It needs to go through the frame disassembly. We've already talked about that as well. It goes through the routing process once again, and then it goes back into the frame assembly because it needs a new layer 1 and layer 2. So then it will send it back out on the line again. It'll go through the switching process again. And then it will get to this router right here. That router will then disassemble that frame and take a look at the IP address, do the ACL, do all the routing process that we've already talked about, and then determine where it needs to go, and then reassemble it and put it out onto this network right here, destined for this web server. So what that looks like here is we've got the Ethernet, the routing, the Ethernet, the routing, the Ethernet. So it puts it out on that line. The switch, once again, there's a switch in this Ethernet portion. So it does the switching process, gets to this end web server right here. And that web server then disassembles that layer 3 and layer 4, make sure, hey, is this destined for me? Does the CRC check on it, the checksum to make sure everything is fine? And once it determines this is destined for me, everything is fine, then it hands it off to the application, and the application is going to then create a response back to that. So that is generally how things get routed through your network. And so we will see that come up again and again throughout the rest of this page here, throughout the rest of this tool here. But I just wanted to cover that to make sure we have a basis of understanding, and that's the basis of how networking happens. So it's pretty important to know. And really, what really this drives home is the interplay between layer 2 and layer 3. Because we see that layer 2 gets thrown away every time we go through this hop, and then layer 3 though remains consistent. Notice that the layer 3 is the same all the way from this assembly part right here to this disassembly. So the packet remains the same for the most part, where the frame gets rebuilt every single hop along the way.